Chromatography is a powerful technique used for the separation of a mixture of substances based on their distribution between a stationary phase and a mobile phase. The concept of chromatography, meaning writing in color, was first introduced by Mikhail Tsvet, a Russian botanist and physical chemist, in 1906. Chromatography has evolved into a valuable method for separating components of a mixture, particularly when they possess similar physical and chemical properties that make separation challenging using conventional methods. The various types of chromatographic methods are based on the differential migration of components in the mixture, depending on their affinity for the stationary and mobile phases. They are adsorption chromatography, partition chromatography, exclusion chromatography, and ion exchange chromatography. Adsorption chromatography involves a solid stationary phase and a liquid or gas mobile phase. When the mobile phase is a gas, it is known as gas-solid chromatography (GSC), and when it is a liquid, it is referred to as liquid-solid chromatography (LSC) or column chromatography. Adsorbents such as silica, alumina, and calcium carbonate are commonly used in column chromatography. The separation is based on the adsorption affinity of the components to the solid phase and their elution by the mobile phase. Partition chromatography utilizes a liquid stationary phase supported by an inert solid material, with the mobile phase being either a liquid or gas. Liquid-liquid chromatography (LLC) involves a liquid mobile phase, while gas-liquid chromatography (GLC) employs a gas mobile phase. This method relies on the differential partitioning of components between the stationary and mobile phases, enabling their separation. One such popular chromatographic method is paper chromatography, where a strip of filter paper acts as the stationary phase. The mobile phase, typically a mixture of organic solvents and water, moves along the paper, carrying the components of the mixture with it. Depending on the direction of the mobile phase flow, paper chromatography can be classified as ascending, descending, or radial. The separation is visualized as spots or bands on the paper, and the ratio of the distance traveled by a component to the distance traveled by the solvent front is known as the RF value, which aids in component identification. The following shows the diagram of paper chromatography. Thin layer chromatography (TLC) is another partition chromatographic technique that employs a glass plate coated with a thin layer of the stationary phase. It offers a wider choice of stationary phases and greater separation capacity compared to paper chromatography. TLC is highly sensitive, allows for the separation of minute quantities of compounds, and provides sharp separation with high speed. The following shows diagram of TLC. Exclusion chromatography separates components based on their molecular size using a gel permeation or sieving technique. Gel permeation chromatography or exclusion chromatography involves the use of three-dimensional networks of cross-linked polymer chains as the stationary phase, allowing smaller molecules to penetrate the interior of the gel and be separated. Sieving separation utilizes zeolites or molecular sieves with permanent cavities and channels that selectively retain molecules based on their size. Ion exchange chromatography involves the reversible exchange of ions between a liquid phase, mobile phase, and an insoluble ion exchange resin, stationary phase. Cation exchangers exchange cations, while anion exchangers exchange anions, allowing for the separation of ions based on their charge and affinity for the resin. In conclusion, chromatography is a versatile method used for the separation of components in a mixture. It has various applications in fields such as chemistry, biochemistry, pharmaceuticals, and environmental analysis. The different types of chromatographic methods offer unique advantages and are selected based on the nature